Hello, everybody. My name is Andrew, and I am with my partner Yangjie and Andrew. And today we will be presenting on Slater's rule and its application in real life. So to begin with, what is Slater's rule? For one thing, as chemists usually know, there is a force of attraction between the nucleus and the electron in a certain subshell N. Now, this force of attraction is typically hard to calculate unless it's a one electron atom or it's hydrogen. As for why, it's because typically there are multiple energy levels in the inner shell that have a force of repulsion against this specific electron. To put this in simpler terms, imagine that there is a main character in a certain TV show, right? And he has a certain attraction to the main girl right over here. And this girl is basically the nucleus. Now, the problem here is that it's not a good TV show if it's just a boring love story and then they just get with each other and it's all, oh, nice, how fun. There are no problems here. So there are a bunch of side characters here who are also being attracted to the girl or the nucleus, and they will try their best to push this main character away from the girl. This is like the force of repulsion experienced by the electron that we are focusing on over here, as these electrons in the inner shell are trying to force this electron away, since they are the same charge, and as a result, there's just a force of repulsion. Now, we want to find the force of attraction that is still being experienced by the electron, but with this constant force of repulsion, it's going to be a lot more difficult. Slater, when he was finding the general force of repulsion, he found a general trend depending on the group that these inner electrons were in. And then he summarized numbers to associate with these groups of inner shell electrons, and that would basically be their values when calculating the force of repulsion experienced by the main electron that we are focusing on.
So now I'm going to give an example of what it would be like to calculate the effective nuclear charge for an electron using Slater's rules. The atom we're going to be looking at is going to be scandium, and this has a Z value of 21, which means it has 21 protons. Now, if we look at the electron configuration for scandium, we see that this is what it looks like. And now say we want to calculate the effective charge experienced by an electron in the 3s2 orbital. In order to calculate this effective charge, we would take the total charge minus the repulsion from all other electrons. And we can calculate this repulsion by basically taking a sum of how much each electron multiplies uh, and multiply that by the number of electrons that there are. So for instance, for the 4s electron, because this is higher than the 3s2, this has a repulsion of 0, so we can ignore this. If we start at the bottom and we look at the 1s2, these electrons are going to have a repulsion of 1.00, and multiply that by 2 electrons means 2. For the 2s2, 2p6, these electrons are going to have a repulsion of 0.92, and we can multiply this by 8 for 8 electrons. Now, for the s and p electrons, we see that for the 3s electron, there is going to be 7 s, 3s, and 3p electrons that are going to have a repulsion. Each one of these have a 0.32 repulsion, and there's 7 of them. So we multiply 7 by 0.32. And then for the 3d electron, we see that there's 1 electron, and this has a repulsion of 0.04. Now, where do we get these numbers? These numbers are calculated by looking at the ionization energy of different atoms. And by looking at this ionization energy, you can mathematically calculate what these numbers shall be. Now, if we take the solution of this is going to be 21 minus this repulsion factor, which is going to be equal to 9.36. So basically, for scandium, this is the n equals 1 shell, this is the n equals 2 shell, and this is the n equals 3 shell. The amount of force and the potential energy of this electron in the 3s2 orbital, in the 3s orbital, is going to be equivalent as if the nucleus had a charge of positive 9.36. And for reference, this is what Slater's rules look like in more depth. Now, what are some of the applications of Slater's rules? Well, there's so many applications, such as calculating ionization energies or promotion energies, but the one that we're going to be talking about now is periodic trends in the periodic table. Now, we mostly understand why, as we go down a group, things like radius, ionization energy, and electronegativity change. Because more shells are unlocked, the radius is obviously going to increase, and that means that the attractive force between the outermost electrons and the nucleus is going to decrease, which would lead to a decrease in ionization energy and a decrease in electronegativity. But this trend isn't as clear when we go through the period. Now, it's often said that it's because more protons are added, but more electrons are also added, right? So it doesn't really have a clear meaning. Slater's rules show that as we go towards the trend, the effective nuclear charge is going to increase. And if the effective nuclear charge is going to increase, that means that the attractive force will be greater and the ionization energy is going to increase and the electronegativity is going to increase. But the radius is going to decrease because it's going to pull the outermost electrons closer towards the nucleus. And in fact, this is exactly the trend that we see in the periodic table. So Slater's rules helps to give a pretty good explanation for these trends.
All right, guys, thank you for watching. If there is anything that you should have learned from this video, it is how Slater's rule is applied and calculated, why Slater's rules exist, and the periodic trends that are caused as a result of Slater's rules and the shielding electrons. Another minor life lesson that you should have learned is that opposites attract. So try to make yourself as different from your crush as possible. And I have also learned why I cannot get a girlfriend. Thank you for watching and see you next time that we have a video project due over the weekend.
Recording
But
videos.
it sucks because like the only thing, like I stutter a lot, and then like the only thing I speak well with a good flow is like nyaing.
Nya 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 nya.
I wanna nya. What is nya?